This lesson shows a second example of how to graph quadratic functions from standard form. For this function, y equal negative x squared minus 2x plus 3, the leading coefficient is negative, so the graph of the function opens downward. Next, use the formula to find the equation of the axis of symmetry, negative b over 2a. The linear coefficient b is negative 2, and the leading coefficient a is negative 1. Then a negative 2 is positive 2, and 2 times negative 1 is negative 2. Then 2 divided by negative 2 is negative 1. And the axis of symmetry is the vertical line x equal negative 1. Draw a vertical line through negative 1 on the x-axis. Since the vertex is a point on the axis of symmetry, x equal negative 1 is also the x-coordinate of the vertex. So to find the y-coordinate of the vertex, evaluate the function for x equal negative 1. Negative 1 squared equals negative 1. And negative 2 times negative 1 is positive 2. Then 2 plus 3 equals 5. And negative 1 plus 5 is positive 4. So the vertex is a point at negative 1, 4. Next, find and graph the y-intercept. The y-intercept is always the constant term of the equation. So for this function, that's 3. So graph the y-intercept at 0, 3. Since this point is 1 unit to the right of the axis of symmetry, there's another point 1 unit to the left. Finally, calculate at least one more nearby point. Select a value of x anywhere close to the vertex, like x equal 2. Then evaluate the function for x equal 2. Negative 2 squared equals negative 4, and negative 2 times 2 equals negative 4. Then negative 4 minus 4 equals negative 8. And negative 8 plus 3 equals negative 5. And you have a point at 2, negative 5. Since this point is 3 units to the right of the axis of symmetry, there's another point 3 units to the left. Draw a smooth curve through the points, and you have a graph of the function. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.